The problem statement asking us to find the solution of this differential equation. It is the first order differential equation. Actually, what you can do is just that you can use the technique of differential equation, the first order differential equation, to find the solution of this one. Okay, but I just would like to use this example to show how to find the solution by using the power series. Okay. So if we want to use the power series to find the solution of this differential equation, what we got to do is just that assume y is equal to summation of an x to the power n. Actually, it's got to be an minus x0 to the power n, but this one is just assume that x0 is equal to 0, or this solution is the solution for the point of x0, x equal to 0. For our differential equation, we have the first derivative of y, so we do the first derivative of the y that we assume. So we get an times x to the power n minus 1, and then we plug the value of y in there, y and the first derivative of y into our differential equation. So we will get this term. So we have x squared here. If you put it into your summation and combine it with the term of x to the power n minus 1, we would get x to the power n plus 1. And for your right hand side, you would get summation of an times x to the power n starting from 0 to infinity minus x minus 1. If you take a look at this term and this term, I just move the term of x to the power n to the same side as x to the power of n plus 1. Now, these two terms, you cannot combine them together because the power of x is different. So, if you want to combine them together, you got to make the term of x to the power of n plus 1 to become n. In that case, you got to do the shift of index of summation of the term of x to the power n plus 1 by replace the n with n minus 1. So we do this. N minus 1 equal to 0, and an become an minus 1. This term n is equal to, turning to n minus 1 and x to the power n. From that, you would get the summation of the first term starting from 1 to infinity. Okay, the terms on your left hand side, the first term on your left hand side is starting from 1, but the second term starting from the 0, right? And now you still cannot combine these two terms together because the first term starting from n equal to 1, but the second term starting from n equal to 0. So you got to make the starting point the same. So then what we do is just that we replace n equal to 0 for the second term, we would get a0. Okay, but the thing is that I have seen x here. So the x would come from this term and this term, right? X to the power 1. When you replace n equal to 1, then you would get the x term. So from this one, I would put n equal to 0 and n equal to 1 because I already observed that on my right hand side I have x there. Okay. So then I put n equal to 1 again there. I would get minus a1x. And the rest of the term, I just put it as the summation. The first term is starting from 1, but the second term I already did it to 2. So the first term I have to put the value of n equal to 1 into this function and then write the summation starting from n equal to 2 to infinity. When I plug n is equal to 1 there, I got a0 times 0. So that means I got 0 there, so I just put there. and then plus the rest of the term of this one, which is the summation of an minus 1 times n minus 1 times x to the power n, where n starting from 2 until infinity. Now, these two terms, I can combine them together, right? These two terms, I can combine them together because they have the same power of x, and also for the n, which is starting from 2 until infinity, which is exactly the same. Now I do rearrange the terms again. Okay, I got a0 minus a1x plus summation. These two terms, I can put them together. I would get an minus 1 times n minus 1 minus an and the whole thing times x to the power n equal to minus 1 minus x plus 0x to the power n. We can use the comparing of the coefficients. A0 actually it sounds like we have x to the power 0 there. So if you're comparing the coefficient of x to the power 0, you would get minus a0 equal to minus 1 or a0 equal to 1. The second term is comparing the coefficient of x to the power 1. You would get minus a1 is equal to minus 1, so my a1 is equal to 1. And then comparing of the coefficient of the terms of x to the power n, I would get an minus 1 times n minus 1 minus an equal to 0, or an is equal to an minus 1 times n minus 1. But this one would be, we would be able to use this one when n is greater or equal than 2, right? From our starting point of n there. Now, I want to know the relationship of a from a1, a2, a3, a4, and so on. So I just put the number of n equal to 0 there. I would get a0 is equal to a1, which is a1 is equal to 1. Okay, so I just put 1 there. For 1 factorial, I would do it after I know the rhythm of it. If I know that the rhythm of it will become 2 factorial, then I put 1 factorial. So first of all, I would put 1 first, and then I just replace n equal to 3 to see what's going to happen next. And then when I put n is equal to 3, I would get that a3 is equal to a2 times 2. But my a2 is equal to a1, so it's 2 times 1. I'm still not sure whether it is a factorial yet, so I just put a equal to 4, and then a4 is equal to a3 times 3. And my a3 is equal to 2 times a1. Now, it's obviously that it's become factorial. So from this point, I would say that, okay, it's equal to 3 factorial. So up here, I put 2 factorial there and 1 factorial. And now I can guess that for n is equal to 5, a5 would be equal to 4 factorial. And as rhythm, so that's why an times n minus 1 of an, it would be equal to n minus 1 factorial. Because I know from this. Although this one, I know that my an is equal to an minus 1 times n minus 1. But this one, I cannot conclude that it's equal to n minus 1 factorial. I have to write it down in the terms of the number in order to know the rhythm of the function. Then finally, I would end up with my an is equal to n minus 1 factorial. So from this, the solution would be, this is whatever I just assumed from the beginning. And then I just write this term, kind of distribute this term. So I would get a0 times x to the power 0 plus a1 times x plus a2 times x to the power 2 times a3 plus x to the power 3, and so on. And then I plug the number of a0, a1, a2, a3 there. I would get 1 plus x squared plus 2 factorial x to the power 3 plus 3 factorial times x to the power 4. So from this, I said that you can write down in the terms of summation. but x1 and 1 and x1 is not following the rhythm of the summation. So what I do is just I take these two out and then put the rest as a summation of n minus 1 factorial times x to the power n. But this one, my n not starting from 0, it's starting from 2. Then I would get this term. Okay, and that's the solution. But like I said, after you get the solution, you've got to check the radius of what? The radius of convergence. This one. You better check that this solution would be convert to every x value or not, or it converts only where x is equal to 0, or if our radius of convergence is a number, then you got to find the range that the solution is satisfied, which is convergent, convert. So from this, I just using the definition of radius of convergence. Note that the law is equal to limits of an divided by an minus 1, n is go to infinity. My an is equal to n minus 1 factorial, right? Because we proved that already. So then my n plus 1 would be n factorial, right? an is equal to n minus 1 factorial. Therefore, an plus 1, you put n equal to n plus 1 there. You would get n factorial, right? So I said that I would get n minus 1 factorial divided by n factorial. N factorial is equal to n times n minus 1 factorial, right? So these two terms cancel out. So I would get 1 over n, and my n is go to infinity. So that means the limits of the radius of convergence is equal to 0. If it is going to 0, it means that this power series converts only at x equal to x0. Now our x0 is equal to 0. So this solution can be used only when x is equal to 0. So that means it's not a solution that you can use in every case. You can use only where x. So it's just the answer around x equal to 0. So in that case, I would say that it's not the answer of this differential equation, because it can be used only some certain point. So by this, it just goes to another two words: ordinary point and singular point. Ordinary point and singular point. That we have to know what is it and how important of it.